Alright guys. We are just to start pipeline in ARM processor. Yeah, the beginning was not so cool because sometimes laptop causes some illness when there's no storage left. Anyways, we'll start about pipelining in ARM processors. So, introduction to pipelining. What is pipelining? Nothing but it is a mechanism. See, you always have a process. See, what is CPSI? It's a 32-bit register. What is pipelining? It's a mechanism which is used in RISC processor. CPSR is used in ARM core. Here it is used to execute multiple instructions in parallel, improving execution speed. Why CPSR is? It is used to monitor and control internal operations. Okay, why am I talking about CPSR? You can see that in the previous video. Here we will be focusing on pipelining, which is nothing but a mechanism used in RISC processor to execute multiple instructions in parallel. Remember, what happens by executing multiple instructions in parallel? It enhances or improves the execution speed. So it allows fetching the next instruction while another instruction are being decoded or executed. Like I told you earlier, suppose this is one instruction, this is another. Oh, what is this? Shit. Sorry, no bad languages and all. I'll draw it. Okay, it's like this. Then okay, that was so nice. I have no space, so I have to start from here. So this you have to talk about 1 clock cycle, 2 clock cycle, 3 clock cycle. Instruction 1, instruction 2, instruction 3. Okay. So the first instruction which comes, basically, so for the first instruction is program counter points to instruction. It is fetched. Okay, this instruction is fetched. Whereas these all are nothing. Like in the first cycle, only fetching has happened for the first instruction. In the second cycle, see, the first instruction is being decoded while at the same time the second instruction is being fetched. Then in the third cycle, the first instruction is being executed, the second instruction is being decoded, and the third instruction, this keyboard is, I mean mouse, okay, this second, this is one, it looks like one. Okay, now the third instruction is being fetched over here. It's just like that. Acknowledge or leave out that. See, ARM pipeline stages. So basically, uses different ARM uses many pipelines like 3, 5, 6. But we will talk about the basic 3-stage pipelining in ARM 7. It uses fetch, decode, execute. Fetch is nothing but loading the data from the memory. Decoding nothing but understanding or identifying the data. Execution is nothing but processing or executing the instruction and then writing back the results. Now, as you see, cycle 1, see, same thing, right? Cycle 1 fetched. In cycle 2, this is 1. I'll write 1, 1, 1. Okay, I'll put 2 ones because I am not able to write 2 properly. So this is second instruction. You can understand like this, right? This is third instruction. See, in the cycle 1, 1 is fetched. In the cycle 2, 2 is fetched. In the cycle 3, 3 is fetched. Like same way, 1 is decoded and 1 is executed in cycle. Like it's just like that. Extended pipeline ARM. So ARM 9 is having 5 stage, ARM 10 is having 6 stage. The additional is nothing but memory and write back. You read here that the processes the instruction and write back the results. So we have that stage separately over here where the memory is nothing but load or stores the data. Write back. See, memory sometimes it also works for storing the results. I mean, sometimes you require some data after the execution, maybe like that. So just memory loads or stores the data. So it does both the work. It stores the data and it also sometimes loads the data. And write back nothing but stores results in a register. Same way, ARM 10 is having another stage called as issue. Issue is nothing but before the instructions are being decoded, it just prepares the instruction for decoding. Just imagine the decoding part is nothing but like a brain fight something, so you have to be mentally prepared, right? It's just like that. Impact of increased pipelining length. So it's just higher instruction throughput. See, in ARM 7 you have 3 stages. Here you have 5 stages. 13% increase in throughput. 6 stages for 34% increase in throughput. If you see in the first two, I mean compare 3 stage and 6 stage. almost 34%. You can't say double, but you have 34% increase of throughput. Then the characteristics of pipeline execution: an instruction is considered executed only when it completes the execution state. Unless and until it is reaching the execution stage won't mark it as completed. I mean executed until and unless it finishes the execution. Sometimes suppose you know in this phase suddenly when you come to clock cycle 3 some interrupt happened. So see, this will be aborted and this will be aborted, but this will still keep undergoing execution. That is the rule over here. Okay, you if you read this you will understand. See, okay, it will come down. So program counter in pipeline execution: the PC will always point 8 bytes ahead of the current instruction in ARM, and the thumb state points 4 bytes ahead. Pipeline flush and interrupt handling: see here, branch instruction cause pipeline to flush, restarts fetching from the new address. When an interrupt occurs, see, when an interrupt occurs, the instruction in the execution stage completes, but the other instructions are abandoned and the pipeline restarts from the vector table entry. Vector table will be studying the next part. So we have completed pipelining. I told you it's not a big deal, it's just a small topic, and now we'll move on to the next topic, that is vectors. Let's see, we'll just mark it over here. Wait. So we completed pipelining. Now we have to go for exceptions, interrupts, and vector tables. All three are one topic. Okay. We did not complete this, so I did not mark this. So once we complete this three, this will be marked, and then we'll be left with only one topic of this module. Thank you. See you in the next video.